Hey there, this is Charlie with 4BZ Truth. Hey, thanks for tuning in. I wanted to talk to you guys real quick. I'm one who always likes to try to think outside of the box as much as I can within reason, because sometimes, you know, some of these topics that I get into can be a little out there, and I don't want to throw people off with the topics that I bring up, but sometimes you just have to address it. If it's truth, you know, you follow wherever the truth road takes you, and you know, I just wanted an opportunity to tell you guys what I've come across. Now, first of all, I just kind of preface real quick that everybody has a perspective or a bias in which they interpret information. Not everybody will have an opportunity to see the same evidence or information, but sometimes if they do see the information, sometimes they interpret it from a certain filter of bias or perspective, like evolution versus creation or whatever the case may be. Now, one of the topics I like to talk about nowadays is the Earth flat or is it a globe? Now, first off, I'll just tell you, with the conversations that I've been having with my family, it's kind of gotten around that I'm a little bit loopy. Maybe that's my interpretation of their interpretation of me, but my niece, silly little girl, I love her like crazy, but she made me, and she is one of the most talented crocheters that I've ever seen. Would you look at this? She's trying to convince me that the Earth is a globe. So this has got to be one of the coolest presents I've ever gotten. And the reason I'm saying that is, I mean, no one's ever dedicated that much time to make me something like this. Now, with that said, I'm a collector of globes now. Take a look. I have a little globe here. And the reason I'm collecting these, like for people, they collect comic books, they collect certain like Teenage Mutant Ninja Turtles or something like that. Those are the kind of things I grew up with, and you have something like this. You know, I started realizing I like the thought of having a collection of things. You know, I collected comic books when I was a kid, and I still have them. And sometimes you just like to have those things that are like fantasy that you can engage in and be able to, you know, Dungeons and Dragons, whatever the case may be. But here's another one. My nephew was about to throw this away, and I'm like, no, I'm going to take this. I collect globes now. Here's another one. This is a sweet globe. I got this for Christmas. But this is by far my favorite one, because, I mean, it's a knitted pillow, basically. I can sleep with it. I'm also going to get into the Pan Am 50th year anniversary flight, where they went over both the North and the South Pole in the same trip. So it's going to be interesting. Just stay tuned. Okay, so first of all, you see a picture of this this flat Earth map. I actually just downloaded this so that I can put it on my desktop here. This article, or it was a website that my brother sent me. Now, I actually have been trying to talk to my brother about the flat Earth here and there. He's a conspiracy guy. He likes to talk about the 9/11 attack, the chemtrails and stuff like that. And you know, I kind of have a lot in common with him about talking about the Bible and whatnot, but because there's a lot of conspiracy in the church and whatnot. So I'm not going to play down his perspective, but he's been trying to convince me that the Earth is actually not flat. This website is called wingnet.org, and it's talking about Pan America's 50th anniversary around the world over both poles flight. And they did it in October 28th of 77 through October 30th. So basically they hit all these different spots to go over both poles, and I have a video that I looked up after he sent me that, and I'll just show it to you, the little segment.
This will be the longest and in many ways the most interesting leg of the trip.
Cape Town,
7,550 miles
South Africa,
the South Atlantic, and the frozen expanse
over the South Pole,
over the South Pole, then across the South Pacific to Auckland, New Zealand.
Auckland,
It's the first time
New Zealand.
any plane has flown this route. A few hours after leaving Cape Town, Clipper New Horizons flies into daylight, cruising at an average speed of 532 miles an hour, at an altitude of 43,000 feet. It will cover the distance in just over 11 hours. This is the kind of long-range flying the 747 SP was designed to do, and on Flight 50, the aircraft and engines perform flawlessly. The clouds break up just in time to give passengers a good view of snow-covered Antarctica. You're looking at the very bottom of the world. Its stark, almost mysterious beauty is an unforgettable sight. The first person to cross Antarctica to the South Pole was Roald Amundsen in 1911. His trek took him 17 months. For Clipper New Horizons, it's been a swift 7-hour, 10-minute flight from Cape Town. 5 seconds. 2, 1. Ladies and gentlemen, you're at the South Pole. Congratulations, ladies and gentlemen. This is Captain Mulligan now, and a toast to all of you for the big moment we've been waiting for. Congratulations, and congratulations for being aboard. Someday, maybe, other travelers will fly over both poles on their way around the world. But these Flight 50 passengers can always say, we did it first.
So I wrote these figures down earlier. 7,550 miles, and then 532 miles per hour on average, and they were 43,000 feet in the air, and it took them 11 hours. Now it also mentioned that there was from Cape Town to the South Pole was 7 hours and 10 minutes. So that gives them another 4 hours to get to Auckland, New Zealand. Now, one of the things I wanted to point out is there is a hole in this video because of the times. Now, I did some research, flight times to Auckland, New Zealand from Cape Town, and I pulled up this. This website is called travelmath.com, and you can actually put in a city, get the flight time, and basically I averaged the travel time to 532 miles an hour, and the takeoff and landing time is 0 because I just assumed that maybe they didn't account for that when they were talking about the 11 hours. But the best case scenario for the time frame it would take to fly is 13 hours and 47 minutes, which is like 3 hours longer than the flight that they were talking about doing, which dipped down to the South Pole. Now they said it was 7 hours and 10 minutes to get from Cape Town to the South Pole, which only gave them another 4 hours to get to New Zealand. Now, it's possible that that's the case, but if they were flying on average 532 miles, there's no way they could have done it in that short of a time. So that's one thing, one anomaly with that video that I'm having trouble with, because the other thing is flight time from Auckland to Cape Town. Says it's 11,760 kilometers. Converted to miles is 7,307 miles. And now they had mentioned that the distance that they went was 7550, which I guess if they swoop down to the South Pole, do they go an additional 250 miles? I don't think that that's all they did. It would have had to have been more than 250 miles off course. I mean, if they were to travel direct flight from Cape Town to Auckland. Okay, so really quick, I'm going to show you this one. Got timeanddate.com. The distance from Cape Town to the South Pole. There's 3,882 miles. And then the other I can say Auckland here. I don't know if I spelled Auckland right. Let's see. There it is. Auckland to the South Pole is 3,680 miles. So here's New Zealand up here, and here is Cape Town down here, in the tip of Africa there. So I guess if they went a straight shot this way, hit the South Pole, and then went back this way, it's almost like a straight shot. But let's do a quick calculation here. It's 7,000. Hold on. 3,680 plus 3,882 equals 7,562. So 7,550 is what they said. So that's basically the same. It's about 250 miles longer to go from here to here to here. So instead of just doing a straight shot, it takes them off course 250 miles. That sounds about right. But in terms of the flat Earth perspective, our projection, this would be extremely difficult here to fly from Auckland to, if we were to say the South Pole was over this way or over this way. This is another thing that I'm going to have to look into. But basically, you would have to fly over this and then go this way. So that would be a big triangle. In terms of a conclusion on if this is a legit, flight path that they did, or this right here. They said that they went from San Francisco over the North Pole to London, England, which is not a problem on the flat Earth or the globe. Cape Town, South Africa, over the South Pole to Auckland, New Zealand. That sounds like a problem for the flat Earth, but the question is, are the times correct? Because they're missing about 3 hours off of the flight time. They said it was 11 hours, and also they veered off to the South Pole. So if they're veering off to the South Pole, now one of the other things I was thinking about too was, if you were to travel to the South Pole, here's where I'm getting into like expeditions to the South Pole. Now, you can take cruises that take you to Antarctica, but I'm having the darndest time trying to find information about how to actually get to the South Pole. Now, in light of the flat Earth, I've heard of people going to. In fact, I don't want to name names, but I have a family member that is a marine biologist who has traveled to Antarctica, is according to what I was told. Now, they stayed in McMurdo, I think is what it was called, base, which I believe is on an island somewhere off of this ice shelf here. But in terms of, I actually have two projections. Now, here's one of the things that I wanted to point out. If they were in Cape Town, here's Cape Town down here, South Africa. Well, Auckland, New Zealand would be here. It'd be literally across the longest point of the world here. And if it takes 13 hours, now I've heard stories you can actually, you could take the jet stream, and it'll cut your flight time down significantly because it'll give you an additional 150 miles an hour or something. There's an article that is talking about New York flight goes supersonic. BA jet gets to London in 5 hours and 16 minutes after it hits powerhouse jet stream and hurls it to 745 miles per hour. Now, I've heard in many cases that airplane pilots try to get to jet streams to improve flight times, and usually that's the only way that they can beat the projected time is hitting a jet stream or some sort of wind current. So now in terms of flight times, I'm starting to wonder if the distance really matters that much, because it really depends on how fast you're going. 745 miles an hour. So you can actually do that flight in 9 hours and 50 minutes. This kind of makes me think about one of my previous videos that I made about the moon being cold, or the moon being cold, colder than the moon shade. And I determined that there was a lot of variables on how to consider, the results, because there's so many things to look at in terms of having an end conclusion. And as far as this is concerned, the actual evidence of how long it takes to go the distance between Cape Town and Auckland, it's going to be, whether it's the flat Earth or the globe Earth. I watched another video of Rob Skiba's that showed with Max Igan how he went from Santiago. Actually, he went from Australia to Santiago, Chile, and basically they did that flight in something like 14 hours or something.
So as we look at the Great Circle route that you would take going from Chile, Santiago, Chile, across the Pacific Ocean all the way to Sydney, Australia, you would take this route, which is exactly as he said. You would start out first going south or southwest, and then you would take a little portion of it going west, and then you would go northwest.
Yeah, folks, I've been asleep for about 5 hours.
There you go.
We got it. We're now, as you can see,
So here we can clearly see that the plane is in the portion of the flight that is turning northwest, as seen by the on-screen display.
That's the meeting that I'm getting.
So as we can see here, as he said, in the radar or on the on-screen display, clearly the plane is traveling northwest according to the flight tracker.
Getting a different reading of our compass. Most business comes around. Your reading stars the sun. So they're giving me.
Yeah, I'm actually looking at that on the Gleason's map, and that would tend to agree with the flat Earth map. Max's compass readings, wouldn't it, Jaron?
Yeah, I mean, it definitely would be a southwest from Santiago to Auckland, or that would be southwest pretty much the whole time.
Interesting.
And that's what I keep going back to, is that a whole idea of a great circle. They say you have to travel in that kind of a arc path, which is just not true. You could draw a straight line between Auckland and New Zealand and travel the straight line.
So there you go.
You're off.
That's interesting. So you see, I'm open to things, yeah. But that's interesting.
Yeah.
I found an interesting discrepancy. What caused it? I don't know. Is there a problem with my compass? I don't know. I spin it around. It looked all right. I don't know. I checked it with another compass when I got home. It looked good. I checked it with a digital compass. It looked good. I don't know. That's what it gave me. So there's something interesting.
It is. It's very interesting because, you know, when you look at it on the Gleason's map, we tend to agree with the flat Earth model. Now, are we going to say that's conclusive? Nope, but it's an interesting tidbit for sure.
You can see the black line being the flight's path if it were on a flat Earth. And if you look at the lines that have the green on them, those are lines where the plane would be flying northwest. The line with the purple would be flying about west, and then all the yellow lines would be flying southwest. So the interesting thing there is, when Max said that the second half of his trip, the entire time he was awake, his compass was showing southwest, that would make sense with all the yellow lines, as you see. Remember, north is relative to where you're at with south.
Honestly, I'm getting to the point where I feel like it's possible to take these jet streams, you know, and to cut the time, you know, quite a bit. So 7 hours and 27 minutes at 500 miles an hour. But if it's 745, 4 hours and 40 minutes. So that cuts off 3 hours. A jet stream can make that difference, it seems like. Speed of sound at sea level, 761 miles an hour. So 5 hours and 16 minutes. What do you guys think? I'm interested to get your feedback in terms of what, you know, what to think from all this. I mean, to me, I mean, it does support, I mean, it causes a problem for the flat Earth only because of the flat Earth projection from Auckland to the South Pole, or maybe they just flew over the side of the ice. Who knows where it is? I don't know. As far as the South Pole, but if they flew over the ice and then came back this way, that's a big triangle, which would make it very difficult to do that flight in 11 hours. In light of, you know, the time that I noticed that the best or the quickest time from Auckland to Cape Town, or vice versa, actually, Cape Town to Auckland, like this way and then up this way, would be closer to 14 hours. That's the best case scenario that I could find. And if that Boeing 747 or whatever it was, the Pan Am flight, went that distance, the 7,550 miles in 11 hours, I don't know. It just seems there's too much to account for. So give me some feedback, anybody that's watching this video. Tell me what you think. Maybe you have some information that I haven't considered, and I'm open-minded. I haven't drawn any conclusions based on this information, but my brother actually is trying to prove me wrong based on the distances here. As far as I'm concerned, there's just not enough information to conclude on one way or the other. I mean, yeah, you could lean toward the globe because of how far the distance is here. But again, I don't think any map is correct. And there's a lot of variables to consider when you're traveling long distances, especially if you're taking a jet stream highway. Okay, so here's the video of that flight again. I just wanted to prove a point with some interesting anomaly I just ran into.
And the frozen expanses of Antarctica, at the South Pole, then across the South Pacific to Auckland, New Zealand. It's the first time any plane has flown this route.
So notice how it kind of dips under South America on that projection. Obviously, they need to show it from a globe perspective because I'll show you. Now, if you look, that is the right wing. That is the wing on the right side of the plane. So if you're facing the cockpit on the right side, the sun is coming up. Okay? Now, if you consider it was 1 o'clock in the morning when they left. Okay, here's a picture or an image of Antarctica. Now, if they're flying from Cape Town, okay, so this is what they're saying basically. That they said that it went this way over the pole. Now the thing is, if it went even straight, guess what? Look at this freaking flat Earth map here. And now, if they went around this way, here, get out of the way here. Oh, this is the wrong thing here. If they went around this way, to the pole, the sun actually, because if they left at 1 o'clock in the morning, that means it would be 1 o'clock on the other side here in the afternoon. So 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock. So the sun would actually be over here 7 hours later. It would literally be over Asia. Now, if they're flying over a pole over here, you know, the South Pole, that means that the sun would be on the left-hand side of the plane. That's an anomaly to me. Let's go back to that video and watch the rest of it. I'll show you what I'm talking about. See, the sun's on the right side of the plane. It should be on the left side. So let's keep watching.
Clipper New Horizons flies into daylight, cruising at an average speed of 532 miles an hour, at an altitude of 43,000 feet. It will cover the distance in just over 11 hours. This is the kind of long-range flying.
I don't know if it's really going to show it. I'm looking for the Antarctic shadow casting or whatever. So they're on the right side of the plane. The sun is actually coming from, so look at, see how the sun is on this side of the mountains and it casts a shadow on that side? So that means the sun is behind them. So if they were standing and facing the cockpit, the sun would be on the left-hand side this time. Interesting. It seems like the sun's on the opposite side of the plane now. Ooh, that's weird. You see what I'm talking about here? The sun would be, let's see, it almost looks like it could be yeah, I'm just still trying to wrap my head around this because I just figured this out. It's freaking crazy.
You're looking at the very bottom of the world. Its stark, almost mysterious beauty is an unforgettable sight.
So they're looking out the right side of the plane. Wow, what a crazy turn of events. I'm concluding that this video is fake for several reasons now. The time doesn't work. as far as 11-hour flight. The distance doesn't work. It should only be about 5,000 miles, or plus or minus, based on what they were saying. Well, I mean, even if they veered off to the South Pole, the sun is on the right side of the plane when they're entering into the Antarctica area. And then basically they're looking out the right side of the plane, and the sun is being projected from behind them. And you can see that in this image here.
Web, or aerospaceweb.org. And you see they're going to discuss the way it works with airspeed and wind and ground speed. So basically what they're saying here is that when you take the speed of the plane, so in this particular case, that plane is going 500 miles per hour, and you add the wind behind it, going 100 miles per hour, so now we've got a total air flight speed, according to the ground, of 600 feet. Makes sense, that's what it should be, and I don't understand why it wouldn't be. But if we look here, our ground speed is 611. But if we rock this back and forth, for instance there, we're at a ground speed of 600 miles per hour, a true airspeed of 1139. So here's something interesting that I think might be the case. And then it also shows that the wind is in your face. Well, obviously you're going 500 minus the 100 would be a ground speed of 400. Talks about all these different ways that you come up with these numbers. But the most interesting one, and I saw this from last time, and then I remembered, now I remember what I did. You can figure out this number on your own by taking 2% of the speed added for every 1,000 feet of altitude. Okay, so basically if you take a plane at, say, 40,000 feet, okay, you could take 2% of the speed. So we just saw 611, let's just take 600. Easier number to deal with. So 2% of 600 would be, 1% would be 6, 2% would be 12. Okay, so it's 12 miles per hour. And then you multiply that by the thousands of miles. So we would take 12 times 40, since we're at 40,000 feet. 12 times 40, 0, 0, 0 is 8, is 480. So if that's true, then what's happening here is you're taking the ground speed of 600 miles per hour, the plane speed, 600 miles per hour, and adding the 480 miles per hour, which equals 1,080 miles per hour. Now that's going off of, let me read you 1 second so I can find it exactly. Where was it? I just don't want to go on because I don't want people to think I made that up. So 1 second. Hemisphere properties calculator. Oh, wait, here it is. Okay, so it's right here. So it's talking about these tables were created using the 1976 U.S. Standard Atmosphere. Unfortunately, most textbooks and computer programs that provide standard atmosphere tables only go up to a height between 200,000 and 295,000 feet. Sources that do provide speed of sound values beyond these altitudes are rather contradictory. To extend our tables to 400,000 feet, okay, now I'm reading something that's completely not. All the Mach 1 values provided, nope, that's not it either, sorry. Thought I saw something that I recognized. People have in their head is okay, we can't go faster than 740. Because we did see in this flight, actually, if we look at the replay, that it was going 7 what? I don't remember, 7 something. Let's go back and look real quick and see the replay of this. Because it was going 7 something. Right as it, or was it 6 something? I think it was 7. Right as it hit the part where it went out of view. Let's see here again. So we're starting the replay here. So the plane leaves here, and oops, I'll go down a little bit more so we can see it. Okay, so now we can all see it. So right when it gets here, yeah. So you see right there under ground speed, it's going 718. But it won't show you the true airspeed. The reason why is because when you do the calculations, it's going to come up to over 1,000 miles per hour. And if they showed you, that's 720. If they showed you that this plane was going over 1,000 miles per hour, then it would prove 725. It would prove that the plane is flying a much greater distance. So this is where you have to question things. Is, why is this true airspeed not even tracked? Why are we not getting that? There's got to be a reason why they hide it for just this flight. It's ridiculous. Right here, we got an indicated airspeed. Oh, look at this. Oh, right there. Did I pause it perfectly? Yep. So we got an indicated airspeed of 1,061. It just told us to take your indicated airspeed and add to it 2% of your altitude. So at 33,000 feet, you're talking 3.3 is 1%, so 6.6 is 2% times the 33. So now you got 33 times 6.6. Let me get my calculator. I'm not doing that on paper. 33 times 6.6 equals 217 miles that you would add to 1,061. So, I mean, I don't know. That's baffling. Clearly, there's something afoot here. And everybody who thinks that they understand it and that I don't, I dare you to try and make a video explaining what's going on here, where these numbers are coming from. Because the only way you'll be able to explain them is the same way they explain everything, by just saying it's a mistake, it's an error, that we're paying too much attention to this data. Granted that we're just taking numbers off some app, but at the same time, there's a reason why this is hidden.